All right, solving rational equations. Now, the nice thing is this will involve a couple of things that we've done before. You've actually solved a rational equation before. Something like this would be something you've solved before. Let's go x over 3 plus 7 over 15 equals x over 5. You've seen the fractions sitting in the equation before. Our goal back then when we were solving these was we wanted to make it easier by just eliminating the fractions. So we said, hey, if the fractions were gone, it'd be an easy equation to solve. We're pretty good at solving equations. We don't necessarily like the fractions. So what we did was we took this and we multiplied each term by the common denominator. Okay, so when I look at this, the common denominator is 15. So what we did, we multiplied each by 15, again, because that was the common denominator. So this is what it looked like back then. X over 5. So we wrote a 15 by each one. And then we went through and did our multiplication, so it did our canceling. So 3 goes into 15 5 times. You got 5x. Okay.
Thank you.
15's cancel. Plus 7. 5 goes into 15 3 times. Leaves you with that 3x. The purpose was it gave us something easier to solve. That was the nice thing. So our entire goal of this, I'm just going to rewrite it up here. 5x plus 7 is 3x. Was this gave us something that looks a lot easier to us. That's the nice thing. We get something that looks easier. Definitely looks easier than with the fractions. Okay. Now we're back to working our old process. 7, negative 2x if I move the 5x over. And so then x would be negative 7 halves. So our process, and this was our rational equations back then, we just had numerical pieces. Took our common, that helped us get rid of the fractions. Then we solved the resulting equation, which I'm not going to say the resulting equation is always easier, but it's easier than the original one. That's the nice thing, it's easier than the original. Now here comes some stuff that we saw before, or in the last time. The last few classes, we've been working with rational expressions with variables on the bottom in that denominator. Same process. Okay? I can solve an equation much easier if the fractions aren't there. So my goal is going to be take that common denominator, and the last time it was 15, multiply by that common denominator. Things cancel. I get something that looks a little easier. We've been adding and subtracting rational expressions. We know how to find the common denominator. So let's go through our process again. For our common denominator, and I'm going to multiply both sides by, for the variable piece, I said if you have trouble seeing what it is immediately, this was our process. We said write the first one down, x. Went to the next one. Do I have an x plus 3? No, I don't, so I need it. There's the common denominator. So nice thing for us, same process, finding it. So we're going to multiply each piece by that common. Just like I did back here with the 15. Now we're going to look for some canceling, so it eliminates those denominators. On the left side, the x's cancel. On the right side, the x plus 3's cancel. And then I'm ready to distribute and put things back together. So here we go. 5 times x plus 3. 5x plus 15. 2 times x is 2x. And there's that equation that's left over that we feel pretty good about solving. It's a lot easier look. So So we put that common denominator to use. All right. Let's see, I'll subtract the 5x. That gives me 15 is negative 3x. Divide. X is negative 5. So we have the same process with a variable expression in the denominator as we do with the numerical one. Nothing's changing on that. Okay? Looks a little worse, takes a little bit more time, but we're still following that same process. Let's go for something like this. Let's go x over x plus 1 plus 5 over x equals 1 over x squared plus x. So we're going to bring in a few things that we have also seen before. First off, if something's got to be factored, we've got to get it factored. So when I look at that right side, that x squared plus x, we've got to get that piece factored there. So if I factor that x squared plus x, we've got to take the x out. Always factor if we can. So I'm going to take out the x. Leaves me x plus 1. Then I'm looking for my common. The common denominator will be, in this case, x and x plus 1. Again, though, if you struggle, let me get this rewritten down here. Follow your process. And the process was, hey, write the first one down, x plus 1. Go to the second one. Do I have an x? No, I don't, so I need it. Go to the third one. Do I have an x? Yes. Do I have an x plus 1? Yes, I've got them all. So that's my common right there. Then I cancel. Over here, just the x plus 1 goes. X times x, x squared. In the middle, the x's cancel. So it'd be plus 5x plus 5. On the right side, both the x plus 1 and the x cancel. Leaves me just 1. Now we're left with a quadratic. No, a quadratic equation is going to be more work than this linear one, but it still looks better than the original one did. Those denominators are gone. All right, so now we're back to what we've done in a previous unit. If I'm solving a quadratic, what I'm first going to do is get it equal to 0. So I'm going to bring that 1 over. X squared plus 5x plus 4. And then if we're solving that quadratic, we're going to factor. Okay? It's a little more work, but again, familiar work. Right, we get some stuff we've done before. So we're going to factor this. X plus 4. X plus 1. 0. And if you remember, we set each piece equal to 0. We did in that last unit. So x is negative 4 or x is negative 1. Now, one thing that is different, process stayed the same, but one thing is different in solving a rational equation with numerical denominators versus variable denominators. We have to take into account the domain restrictions. So domain is one of the first things that we did with these rational expressions. So if I look back at this, the domain of this one is x can't be 0, x can't be negative 3. Well, I got a negative 5. I'm good to go. Nothing wrong with that. Over here, domain restrictions are x can't be negative 1, x can't be 0. I have a problem. One of the answers I got was a negative 1. Okay. That means this one is thrown out. There's my answer. It's what we call extraneous solutions, which just means extra ones that don't work. We solved it out. We got two answers, -4 and -1, but the -1 won't work in the original problem. It goes against the domain. Notice the solving process did not change. Let's get a different one here. And we'll talk about the domain in this one. Let's go 3x over x minus 3 equals 2 plus 9 over x minus 3. So as far as the domain is concerned in this one, x can't be 3. That should look familiar from a few classes ago. It can't divide by 0, so x can't be 3. I have no idea what I'm going to end up with. If I end up with a 5, 5 is the answer. If I end up with a -2, -2 is the answer. If I end up with a 3, I got a problem. Okay? All I know right now is x can't be 3. My common denominator. Well, the nice thing in this one is I only have one denominator. The x minus 3, remember 2 is over a 1. So if it helps you, you can write the 1 underneath. That is where it's up to you. I know it's there. But I'm going to multiply each one by x minus 3. I'm going to do my canceling, get my resulting equation, and then solve that. So on the left side, x minus 3's cancel. Leaves me just 3x. Equals. Nothing cancels here. That's just a 1. So I'd have 2x minus 6. Far right. X minus 3's cancel. Plus 9. And there's my resulting equation I'm going to solve. So I'm not going to have to factor this when I'm back to something a little bit easier. I can combine like terms on that right side. Gives me 3x equals 2x plus 3. Subtract my 2x. X is 3. And remember, it can't be a 3. This is where we'd say no solution. So we solved it correctly to get the 3. That's correct. We didn't do anything wrong. 3 goes against that domain restriction. That's why we'd say no solution. We did not say no solution for this one because one of them still worked. One of them still works. So we weren't worried about that. Let's go with this. Let's go 1 over x minus 4 equals 8 over x squared minus 16. First thing we should do, factor that right side. X squared minus 16 factors to x plus 4x minus 4. Simple and compound, right? Yeah. And it's on the test. They gave you the formula. Yeah. And we factor. And that actually ends up being the common. And x plus 4x minus 4. So on the left, x minus 4 cancels. That gives me x plus 4. 1 times that. Here they both cancel. That gives me 8. I get a nice simple equation there to solve. That one's not too bad. Subtract my 4 over. I get x is 4. And then we have to decide, can x actually be 4? No. There's where I'm getting that no solution. Can't be 4. It's not affecting how I solve the problem. That's the part you got to realize. Didn't change anything about how to solve the problem. We did the correct process. Getting that 4, that just can't be our final answer. I don't know that in the beginning. Let's look at another one we'll have to factor here. Let's go x minus 14 over x is 5. Common. Nice thing is there's only one denominator, just the x. So my common is going to be x. I'll multiply everything by the x. So I'd have x squared. Cancels there. Minus 14. It's 5x. I see that squared. That square, we know by now that's telling us we're going to have to factor. I need it all on one side. So I'm going to bring that 5x over. So x squared minus 5x minus 14, 0. Now I'm looking to factor x minus 7. X plus 2. That'll give me a negative 5 in the middle. So this would mean that x equals 7 or negative 2. So now the decision process comes in. We have to think, do either one of those or both of them defy the domain? The domain restrictions, x can't be 0. Okay? Then so both of those are good. Neither one of them 0. So both answers are good. It's a quick check back to the domain. You don't have to substitute it back in and solve the whole problem. You can look right at that domain. Domain should be pretty easy for us to see what makes a 0 down there. Sometimes we have to factor it first, but we know how to do that. Okay? We got another one of those lessons like the last one where you got a number of things rolled in, but they're all things individually we've done before. We found commons. We've multiplied by a common. We've done domain. We've factored. We've solved the linear equation. Those things we've done. We just have them all rolled into one here again. Okay? All right.